All right, so in this lesson, we're going to talk about what is called implicit differentiation, which is a means of finding derivatives of functions even though you don't know what that original function is. And believe it or not, this can be done if you have a relation of your x values and your y values similar to this equation that you see here at the top of the page, namely this guy. So we don't know what y is. We do know y is equal to some function f of x. That's it. And that the y values and the x values are related according to this equation. So how can we find the slope information, or the dy dx information, even though we don't know what f of x or y are? That's the trick with implicit differentiation. It's a nice little handy tool that'll allow us to do just that, leveraging the power of the relation or the equation that we see here. So, looking at this example down here, we have y squared plus x squared is equal to 2x. And the goal is to find dy dx. So what do we know? We know y is equal to f of x for some function x, or some function f of x. Okay, so y is just a function. So what I'm going to do here is I'm going to replace all my y's with this f of x for the time being. This might be different than what you've seen in class and how to do this, but we'll go through probably how you've seen it before if you're taking a calculus course currently live. All right, so every place I see a y, I'm going to replace it with this f of x. So I want to make it very, very clear that what we have here is a function. So I'm told that, okay, f of x squared plus x squared is equal to 2x. My goal? Find f prime of x, which is the same thing as dy dx, okay? Because y is equal to f of x, okay? So how do we do this? You just derive both sides of the equation as you normally would. So let's handle the left-hand side of this thing first. We're going to have to work with this equation. Let's handle the left-hand side. So notice first that we have one function inside of another. This is going to require the use of the chain rule because we have this f of x inside this bigger function x squared. So how do we derive that? I'd say note. We derive the outside first. You copy paste the inside because this is just chain rule, and you raise this to the first power. Are we done though? Nope, because we have to multiply by the derivative of the inside function. So I have f prime of x multiplied because f prime is the derivative of f of x. All right? So that handles the first term's derivative. Now we need to handle the next guy here, this x squared. That's easy. Derive that. That's just 2x. And that handles the entire left-hand side. The right-hand side is also easy. The derivative of 2x is just 2. Remember what the goal was. The goal was to find dy dx, or in other words, f prime. So we want to get f prime by itself. How do we do that? Algebra. Yes, algebra, whatever. I intentionally misspoke. So how do we do this? Solve for f prime. Okay? So that means we're going to subtract 2x from both sides. So we're going to take care of this, subtract that from both sides. And I'll do this one step at a time so it's 100% clear what we're doing. So I subtracted 2x from both sides. Again, the goal is to get this guy by itself. So the next step is simply divide over the stuff that's in front of this f prime. So what does this give me? This gives me f prime of x is equal to 2 minus 2x all over 2 times f of x. All I did was divide both sides by 2 f of x. Okay? And that's the answer. So even though I don't have a function f of x given to me, I can still find the derivative of this function. So it's like, suppose I were given a function f of x that satisfies this equation, then the derivative is going to be equal to this thing. Okay? So if I wanted to simplify this slightly, I would have 2 times 1 minus x, because I just factored out a 2. Then I have 2 in the bottom times f of x. I can kill off the 2's. I'll just erase them. Why not? Leaving you with that. And that's your derivative. All right? So that's kind of how you go about solving this. If you want, you can replace this with your y information. So instead of having an f prime and an f, you can replace this with a y and a y prime. So I'd say or y prime or dy dx. Let's go with that. Dy dx is equal to 1 minus x over y. So that gets you the answer right there. All right, so why don't we do another example and then see if we can extract a pattern from all of this. All right, let me add a page. All right, let's do another example. So let's do 3y squared plus y plus 1 is equal to x squared. Okay, so again, we do not know what y is. All we know is it's some differentiable function in x. So what we're going to do is implicitly derive both sides. So going along with this, okay, so I'm going to use a slightly different notation for this particular example. Instead of using the f of x notation like what we did above, I'm just going to let it be y. So instead of f's and f's primes, I'm just going to say y and y primes, or y and dy dx's. Either way. But it'll work out exactly the same way. We just have to keep in mind that our y is a function in x. So that's crucial. So how do we derive this first thing? So how do I do it? Well, it's going to be using the chain rule. So we have this 2 that we're going to bring down in front and multiply by this 3 and reduce the power by 1. So this gives us 2 times 3 y to the first, but that's not all, because we have to multiply by the derivative of the inside function, which in this case is just going to be y prime. Okay? And now for the second term, how do we derive this thing? We know that it's a function in x, so the derivative of y is simply going to be y prime. Okay? The derivative of 1, the derivative of 1 is just 0, so we don't have to write anything here. And then the right-hand side is just 2x. Okay? Again, the goal was to solve for y prime. So find y prime, which is equal to dy dx. There's many different types of notations for this. Okay, so notice that I have a y prime here and a y prime here. And I have some stuff being multiplied in front of the first y prime. So what I want to do here is factor out my y primes and then divide over everything else. So we have, okay, let me simplify this first. 6y times y prime plus y prime is equal to 2x. Okay, now I can factor some stuff out. Factor out this y prime. So this gives me y prime times the quantity 6y plus 1. And this is equal to 2x. Again, the goal is to get y prime by itself. So what we're going to do is then divide both sides by the 6y over 1. I mean 6y plus 1. 6y plus 1. All right. So then we have y prime is equal to 2x over 6y plus 1. And that's the final answer. Instead of using y prime, you can use dy dx. Doesn't matter which notation, but that is the final answer. Okay? Let's do one more, and then we'll talk about the general strategy of this. Let's do x squared times y plus, let's do sine of y is equal to, let's go with 1. Keep the right-hand side simple. All right, so now looking at this first thing here, oh, of course, the goal is to find y prime. That is the derivative of y, even though we don't know the original function. All right. So, all right, looking at this first term here, we have two functions in x being multiplied right here. So we have x squared being multiplied by y, where y is a function in x. So we have to use the product rule here. And so how do we use the product rule? We're going to derive the first thing, leave the second alone, and then add on when we derive the second thing, leave the first alone. So derive the first, you have 2x times y plus, you leave the first one alone, x squared, and then you derive the second one, the y. So how do you derive y? The derivative of y is not 1, but y prime, because it's a function in x that we do not know. All right? So when you derive x's, you do it as usual, but when you derive y's, you always have to be careful to make sure you include this y prime. So that handles this first term here, this guy. Now we need to handle the second one. So we have sine. Okay, oops, we're deriving. So to derive, this is again going to be a chain rule sort of thing. So we have sine of y. Y is a function of x. So we have to derive the outside, leave the inside alone. So the derivative of the outside is cosine of y. Leave the inside alone, which is just y. Then you multiply by the derivative of the inside. So that's y prime. Okay? So that takes care of the whole sine term. Then on the right-hand side, you have 0, because 1 derives away to be 0. Okay. So now the goal is to get your y prime by itself. Notice that this term and this term have a y prime. The first term does not. So all the terms that do not have a y prime, we're going to subtract over to the other side. Okay? So doing that, I'm going to subtract from both sides this 2xy minus 2xy. And then this gives me x squared, y prime, plus cosine of y times y prime is equal to minus 2xy. Just subtracted 2xy from both sides. You leave all of your y prime stuff on the same side, or you try to get it all on the same side. So now notice we have a y prime in both of these terms. I'm going to factor out a y prime. So this gives me y prime times x squared plus cosine of y. So I factored out the y prime. All right, and this is going to be equal to minus 2xy. Final step, as you can probably tell, again, keep the goal in mind always. The goal is to get y prime by itself. So we're going to divide both sides by this huge thing that's being multiplied by y prime. So what does this give me? It gives me y prime is equal to minus 2xy all over x squared plus cosine of y. And that's the final answer. You did exactly what it was supposed to do. So what were some of the key strategies here? So starting at the very beginning, line for line, what do? we derived both sides in terms of x. That's how we got this line here. We just derived everything in terms of x, and then made sure that we were very careful and get y primes where we took derivatives of the function y. The third line, the goal again was to find y prime. So we got all of our non-y prime stuff to the right-hand side, and we kept all of our y prime stuff on the left-hand side. So then we factored out our y prime on the next line, and then divided over to get the y prime by itself. That's the general pattern. So you derive, get your y prime stuff by itself, and then you divide over everything else, probably by factoring. Okay? So that's the general idea. If you want to see this strategy or reference this strategy, you can see it written below this video. It'll help you in all the examples to follow as you work some of these problems yourself. And if you are working on an example and you're not exactly sure how to proceed, those very same steps that I just verbally said will be written down for you in each of the example cards. So get cracking on those examples, and if you need help, I'll be here.